for situations in which Another class of sharding algorithm has been created for situations in which processes are easily classified into different groups. For example, a common division is made between foreground processes and background processes. These two types of processes have different response time requirements and so may have different sharding needs. In addition, foreground processes may have priority over background processes. A multi-level queue sharding algorithm partitions the ready queue into several separate queues. The processes are permanently assigned to one queue, generally based on some property of the process, such as memory size, process priority, or process type. Each queue has its own sharding algorithm. For example, separate queues might be used for foreground and background processes. The foreground queue might be scheduled by an round-robin algorithm, while the background queue is scheduled by an first-come, first-served algorithm. In addition, there must be scheduling among the queues, which is commonly implemented as fixed priority preemptive scheduling. For example, the foreground queue may have absolute priority over the background queue. Let's look at an example of a multi-level queue sharding algorithm with 5 queues listed below in order of priority. Here, this one. The highest priority is system processes, then interactive processes, then interactive editing processes, then batch processes, and student processes. So from up down, the up has the highest priority and the down has the lowest priority. Okay, so each queue has absolute priority over lower priority queues. No process in the batch queue, for example, could run unless the queues for system processes, interactive processes, interactive editing processes were all empty. Then the processes in this queue, batch processes, can run. If an interactive editing process entered the ready queue while a batch process was running, the batch process would be preempted. Another possibility is to time slice among the queues. Here, each queue gets a certain portion of the CPU time, which it can then schedule among its various processes. For instance, in the foreground-background queue example, the foreground queue can be given 80% of the CPU time for round-robin scheduling, and the background queue receives 20% of the CPU to give to its processes on a first-come, first-served basis.